for the invitation, and I would like to appreciate the organizers of this conference. I'm really glad to be here. I've learned a lot from different presentations and research work. Well, my submission this evening and in this year's conference is now totally different from prevailing issues. It's not totally different from prevailing issues. Most importantly, the global problem of our environment. But one crucial information that every one of us in different places have to take on is the fact that the climate change that we talked about and keep talking about and possibly will still be talking about has come to teach us a number of lessons. And the crucial one is that we all together are in the same boat. We all are in the same boat, which is the planet Earth, and it's a responsibility on us to do all we can to make it work. So this therefore gives rise to the need to carry out this study, looking at inward search for outward survival. I'll be focusing on peat because it's important to say my presentation is part of my PhD research in Poland, and it focuses on alternatives to peat. And peat, by its component, of course, is a major component that is used in forest gardens. Forest nursery and horticultural gardens. It is often used because of its major component as substrate medium, and because of the fact that it possesses a very perfect physical, chemical, and biological properties. Of course, it is high in retention capacity and predictable, consistent quality of good stuff for growing plants. Gruder in 2012 did reported that the utilization of peat is over 90 million square meters annually. The area of land excavated annually is over 90 million. And as a matter of fact, CIFOR in 2012 also, I think 2018, also reported that peat loss could emit up to 2,800 year watts of carbon. You can imagine that in our environment. And obviously this is a problem. Releasing that to the system is really a problem because peatland, of course, stores 1/3 of the world carbon, possibly more than what we have in the world forest. So it is important to consider an alternative, and different stuff has been going on in different places across the globe. For peat, when its carbon content spreads on the field or on the plantation, it quickens into carbon dioxide, totally into green gas level, and of course leading to destruction of our treasured ecological system. And 20,000 annual digging is done, and this is of course a big degradation to our world. The European Union has concluded by 2030 that the utilization of peat has to come to an end. And according to a report I saw about England, United Kingdom, has proposed the ban of peat by 2024. So if all of these has to be done, and peat will no longer be used, somehow we have to survive. they need to look inward to survive outward. So what are the strategies for survival? First, peatland should rather be preserved and not destroyed. Remember, we need to store carbon, right? Then we need to look for an alternative to peat. Then this comes to having the substrate concept. But for this study, actually, the whole concept is taking from the forest, the waste and all, and of course, bringing back something useful. Some of the product of the forest often regarded as waste products used for landfill, burnt oil, and all that. They're put together to build up a substrate medium and a bigger research task are considered innovative technology for the production of substrate and fertilizer produced in indigenous source for the production of forestry seedlings. Now, for us in Poland, we had a project, and the project, like I said, is trying to build an alternative to peat, and we used resources that are readily available, that are very cheap, they're sustainable, and of course, very importantly, environmentally friendly. Everything brought together to build up a substrate. And of course, just like a simple trial, not only the substrate, also a fertilizer was built by the University of Agriculture, especially my faculty. And here is just a kind of a trend of production in this slide. And of course, you could see by the left, far left, is the team head of the research, and that's my supervisor for this study. Right. They therefore designed the objective for this study to investigate the adaptability of forestry seedlings. Focusing this report or this presentation will focus on beech and oak, European beech and pendulum oak, in an innovative peat-free organic substrate and fertilizer, which is liquid, that was designed by my university here in Poland. So, peat substrate for this study was produced in the Norway, and of course the fertilization substrate. We have a standard, and the standard is the peat, and the solid fertilizer. So this was there, of course, and of course compared with an innovative substrate. So for the sake of this presentation, SR represents the standard, that's the peat and the solid fertilizer formulation, and the novel substrate is represented in this presentation as UR. Right. So the experiment was laid in a 2x2x4 factorial experiment in a randomized completely block design comprising of two species, which is beech and oak, 2 fertilizer, which is forest, solid and liquid, and of course 4 different substrates. The table here 1 and 2 shows the properties of the substrate. Of course, the contents were a little different from each other based on design, and of course the process of milling and hulling. So seedlings were grown. Interestingly, the seedlings grow. They all grew, of course, even in the new concept. And after a period of nursery growth, like you can see in this picture, samples of seedlings were collected from the nursery, and of course the above ground and below ground was evaluated to check the concentration of elements in the seedlings, just a trial to see if this will survive beyond the nursery stage. And the seedlings were dried, of course, and milled into powder for further laboratory analysis. And the result of volumetric filters shows that these are a number of parameters: the stem height, the stem girth, the total root length, the root area, the diameter area, that's root diameter area, and the root volume were assessed for above ground characterization. Meanwhile, looking at the results of stem height reveals that the control, which is the state, remember I did mention earlier that SC represents the state, which is the standard has been like pitch substrate, yeah. Pitch substrate are the highest height, and pitch substrate again has the guards almost like the same trend. But interestingly, when we look at the third or the fourth column where I have TRL, that is total root length, it's interesting to see that the novel substrate performs best. Not only that, when we look at the diameter, that's the second to the last column, ARD, the novel concept also performs best. Right. And across all the 8 treatments, there was a very clear significant variation according to the results. Very high significant variation amongst the treatments. And this first table, table 3, is the result for beech, Fagus sabbatical. And we're looking at the result of Quercus robust, that's oak. It also had the same trend where the old standard tends to have the highest value. But just like it was observed in oak, in beech, the same thing was said in oak. When we look at the total root length, the highest was also recorded in the novel substrate medium. And of course, this is really interesting. Now, considering the nutrient content in the root system, now I'm trying to look at the 2 species now. The percentage of carbon content tends to be higher in beech, of course, than in oak, across all levels. Across the treatment, it was higher in beech, and when we look at the content of nitrogen, it was the other way, quite higher in oak, and of course the moving nitrogen content, of course, is less than 1%. And the same was, it was quite not stable, considering the phosphorus content. It's higher at some point or in some treatments in oak, and in other treatments is higher in beech. And of course, almost the same thing was observed when we look at the content of calcium and sodium and calcium. Oh, no, I think I made a mistake. I have, okay, phosphorus, potassium, sodium, calcium, and of course, magnesium. Now, based on the results of the study, the substrate medium developed under this study, of course, proved to possess qualities not worse than the standard, which is the pitch. And of course, it has been proven that the different substrate treatment caused a significant variation in the assessed parameters for the root system and the biometric features of beech and oak, and also that the effect of this treatment were visible in the root formation and the element concentration in the root system of this species. Interestingly, the novel peat-free organic substrate and fertilizer, that is the liquid fertilizer designed by the University of Agriculture in Krakow, Poland, have shown strong competitiveness with organic peat. So the root system is adequate well developed to tap into the soil for nutrients and was necessary for plant growth as they guarantee support for plant growth and survival. You know, it's interesting to see that the novel substrates perform really well when it comes to root system. And if the root system is okay, then we can trust to good extent the above ground survival of any of such plant. Well, this is part one of this presentation, and the study is ongoing, of course. The next stage is that the seedlings haven't survived well in the nursery, now trying to plant them out into the forest and see how well they can continue with the growth in the forest. Well, maybe in the next conference, the second part of this presentation will be delivered. Thank you very much for listening.